Alright, so today we're subtracting numbers for the first time. We never subtracted anything in this class. Let's do it. It's going to be super easy today. So the idea here is we should first define exactly what we mean by subtraction before we go on subtracting anything. We have no business subtracting if we don't know what subtracting means. So here, anytime you have a number such as, let's take 10. Suppose you're subtracting 2 from it. We will have a very, very rigorous definition for subtraction now. The trouble with subtraction is that it's not commutative, it's not associative, there's nothing good about it, really. Per se, there's no redeeming qualities. All our axioms were for multiplication and addition. So wouldn't it be nice if you could translate and convert every subtraction into an addition? That would be awesome, because then you could use associativity, commutativity, everything. So that's exactly how we define it. We define it in a very, very powerful way. We will say this is equal to 10. What you do is you just stick that over there and slide it over and replace it with a plus. So it becomes 10 plus negative 2. That's the definition of any subtraction problem. We will take that as a definition. To subtract means the additive means add the additive inverse. Again, to subtract 2 means add the killer of 2. That's what it would mean. Once you do that, everything becomes easy, because now you can turn every subtraction problem into an addition problem and use all our addition skills and all our addition theorems and all our addition axioms. Okay, just want to try it. Let's try an example. See how it goes. Suppose you wanted to do 10 minus 3. So one way to do this would be to go something like this. This is negative 10 plus negative 3. That's by definition of subtraction. And look at it. In the first step, I've already turned it into addition problem, something much, much more familiar. For example, here I could do 2 negative pieces add together to make a bigger negative piece. That's negative plus negative theorem, and you're done with that. That's how you subtract. Okay, that was too easy. Maybe try another example. Here we've got to be careful. I have 12 minus 3 times negative 2. That times glues it together, so this is one term, one item, one term. This is not negative 12 minus 3 and then times negative 2. These two are glued together, inseparable. First thing I do is I say, you know what, I don't really like subtraction. I like addition. So this is by definition of A minus B. You can replace this with a plus and move that negative, attach it to the actual number that's right next to it. That's the definition of subtraction. Now I can do negative 12 plus, I know how to multiply negatives. That's because I have famous negative times negative theorem. And now I've got to do negative 12 plus 6. This is pretty easy. We've done stuff like this. This is negative 6 plus negative 6. This is by negative plus negative theorem, where we take a big negative piece and break it up into little small pieces, and that becomes negative 6 plus negative 6 plus 6. I slide the parentheses over so these two can do their own killing. The associative law of addition. And of course that's going to give me 0, and it's going to be gone. Additive inverses will kill that into a 0. Additive identity will get rid of the 0. Boom, you're done. Every single step to perfection. Perfection, perfection, perfection. Specifically here we're learning to deal with minus. The minus, just push it that way and replace it with a plus. That's a definition. To add, to subtract means add the inverse. Let's try this one. So I have some stuff here. Because this is times, this is glued together as one item. Minus 2 times negative 4. This is glued together as one item. We talked about this before. This famous idea of terms. This is one term. This is one term. You got to keep them together until you have a valid theorem or axiom to break them apart. So here we go. I'm going to change that into a plus. So I'll have, I could work on this too, by the way. This is 6 minus 2 times negative 4. That would be, this is a given. This would be by negative times negative theorem. Let me see. I could also do it this way. I can know how to do 2 times negative 4. Or I could change it to a plus, minus 2 times negative 4. That's by definition of A minus B. And of course, I know how to multiply negative times a negative. That's a positive 8. That's by negative times negative theorem. And of course, I know how to add numbers that are natural numbers. That's of course by the addition table. And there you go. Very carefully, step by step by step. Okay, keeping the terms together. Don't break up the terms until you have a good reason for doing so, if you do. Very nice example. Maybe we try one more example. Maybe we summarize. We've done the negative plus negative theorem. Two negative pieces give you a bigger negative piece. To subtract means replace it with a plus and stick that negative there. Maybe I do want something more for you. Sometimes you have to do something like this. 3 minus negative 4. That one comes up a lot, so maybe I should talk about it just a little bit. The minus theorem says that you go, you can push that minus there so it becomes negative 4. And so that becomes definition of A minus B. Now here's something you can do. Remember before we said that between a negative and a number you could always squeeze a 1 in there? Do you guys remember that? You should. We did that. That's called the minus theorem. But wait, I could have done that on the negative 4 as well. Or I could just do this by negative times negative theorem. Either way, here's one way to do it. Negative 1 times negative 1 times 4. So I've taken that 4 and I broke it up. I pull out its negativeness from it. That's by, again, by the minus theorem. In fact, I could have done both of these steps at once. This is minus theorem. Minus theorem here to put that, squeeze that one in there, and minus theorem here to squeeze that one in there. And so then I can just reassociate these. Negative 1 times 4. Associative law of multiplication. These ones give you 1 by not. And of course this gives you 4 by multiplicative identity. Okay? Not the only way to do it. I'm sure you can figure out your own way to doing it. By all means, please try to see if you can do it your own way using only axioms or proven theorems. And it should be a lot of fun. Here's one way to do it. Alright, now I'm really done. We'll see you guys here next time. Peace.